Welcome to Brain Vision.
So, for the first part, the 12 ohm resistor and 25 ohm resistor are both in parallel. So the the net resistance or the equivalent resistance for these two, let's call it 1, 2. So this will be equal to, so we go with the reciprocal rule. So we add the reciprocals of the resistance and then take an inverse. And this comes out to be 8.108 ohms. And then this combination, this parallel combination, so basically this equivalent resistance is in series with the 4.5 ohm resistor. So for the equivalent resistance of this combination will be, let's call it, let me just write the notation. So let's call it R1, let's call this R2, and let's call this R3. So R1 and R2 are parallel, and the equivalent resistance of R1 and R2 is R12, and R12, or you can say this parallel combination of R1 and R2 is in series with R3. So the equivalent resistance of this whole combination will be R12 plus R3, because these two are in series, and this comes out to be equal to 12.608 ohms. Now this resistance is again in parallel with, so R23 is in parallel with resistor R4, which let's say is equal to, so that is given to be equal to 18 ohms, and therefore R equivalent, which is basically the equivalent resistance of the whole circuit, will be equal to, so these two are in parallel, so we go by the parallel method again, the reciprocal method again. So we add the reciprocals of these two resistance that are in parallel, and we take the inverse. So doing that and plugging these two values over here, we get the equivalent resistance to be equal to 7.4 ohms. Now, coming to the second part, so we need to find the current in the 18 ohm resistor. So let's use Kirchhoff's loop rule for the loop containing the battery and the 18 ohm resistor. So we have the battery EMF minus current flowing through the 18 ohm resistor and resistance of the 18 ohm resistor. So that I denoted to be R4, and this is equal to 0. So this means that I18 will be equal to EMF over R4, and the EMF is 6 volt, R4 is 18 ohms, and current flowing through that, through the 18 ohm resistor, comes out to be 0.33 amperes. So there goes part 3. Then we have to find the current flowing through the this combination, the parallel combination. So in short, we have to find the current flowing through R12. So we use Kirchhoff's loop rule again for the outer loop containing the battery and the resistor, this parallel resistor combination. So we have 1, 2, R, 1, 2. And then the 4.5 resistor is also included. We are also solving for that. So we are applying Kirchhoff's loop rule for the outer loop containing the battery and the resistor R12 and the 4.5 resistor R3. So we have I3 R3. This is equal to 0. So from here we can find, now since these two are in series, therefore the current flowing through these two should be same. Therefore I3 should be equal to I12. This means that EMF minus I12 times R12 minus to 0. Now we can solve this to find the current flowing through the parallel combination R1 and R2. So let's plug the values now. Oops. This is the EMF. R12, what's the equivalent resistance that we found? 8.108. And R3 is the 4.5 resistor. And solving this, we get the current, which comes out to be 0.4759 ampere. Now this is the current flowing through, that's the total current flowing through R1 and R2. So the whole combination, the parallel combination, carries a current of I12. Therefore, when the current reaches R1 and R2, it divides to go through R1 and R2 in such a way that the voltage drop across each of them is same, because these two are in parallel. So let's say that current flowing through resistor R1 is I1, and current flowing through resistor R2, which is 25 ohm, is R2. And since these two, R1 and R2, are in parallel, the total current will add up to I12, which we found here. And again, because these two are in parallel, therefore voltage across both of them should be equal. So V1 must be equal to V2. So from here, let's apply Ohm's law to each of the voltages. So we have I1 R1 equal to I2 R2. Now let's find I2. So I2 will be I12 minus I1. And let's use this value of I2 over here. So we get I1 R1 equal to I12 minus I1 times R2. So from here, we get I1, which comes out to be, so I1 will be equal to I12 times R2 over R1 plus R2. And let's plug the values now. So I12, we found that to be equal to 0.4759 amperes. R2 is the 25 ohm resistor. Let me just check. Yeah, and R1 is 12 ohm. So solving that, we get I1 to be equal to 0.32 ampere. Now one thing that I might choose to do differently if I solve this problem again will be with the notations. Now if there are like a few resistors, choosing the subscripts to be 1, 2, 3 is fine, but since in this case there are a lot of resistors and therefore lots of current, lots of voltages, it's better to denote the subscript like this. I18 is the current flowing through the 18 ohm resistor, Similarly, R18 will be 18 ohm. The resistance of the resistance will be the subscript of the resistor itself. Uh, Now, yeah, so I3, instead of I3, you can write I4.5, which will be the current flowing through the 4.5 resistor. And yeah, so that way you won't get confused with going back again and checking what your notations are. So like for example, I found I1 over here to be 0.38. Now I'm quite confused about what one represents, so I need to check that. So one is 12 ohm, so this is the current flowing through 12 ohm resistor, and it would be easy if you just write choose to go with the notation with the value of the resistance to be on the subscript. So yeah, now for the last part, so the current in the 4.5 ohm resistor, which is I3, so we find that to be, let me just get the page again. Yeah, so I3, we found that to be equal to I12. So this is equal to I3 as well. So the current flowing through the 4.5 resistor is also equal to 0.4759 ampere. So we find the power accordingly. So power will be for 4.5 resistor will be square R3. Now we plug the values. So we take the square of the current of the 4.5 ohm resistor, multiply with the resistance, and we get V3 to be equal to 1.019 watts. So this is for the 4.5 ohm resistor. And let me just check. So yeah, this is also for the 4.5 ohm resistor, I18, and yeah, thank you.